Okay, so this problem asks us to find the half-life of a substance and how much of it we will have in 2050. So we're going to start with the equation of S is equal to AB to the T. S is our substance, A is our initial value, B is a constant, and T is our time that has passed. So we're going to plug in the values that we have. And we have 100 is equal to our initial of 500. We don't know B, and we know T as 60 because 60 years have passed since 1953. So we divide 100 by 500, and we're going to get 1/5 is equal to B to the 60th. We're going to take the 60th root of that, and that's going to be stored as B. Okay, and then we know the half-life. We have 500 grams when it's at full life. Half-life would be 250 grams because we're going to take 500 and divide it by 2. So then we're going to take that, and we still know our initial value as 500. And we're going to put in big B to the T. From here, we are going to divide by 500, and we're going to get half is equal to B to the T. Okay, so we don't know what T is, so we're going to solve for T. And from here, and the way to solve for T is we're going to take log of B to the T is equal to log of half. And we can move our exponent out in front of log. And we're going to rewrite it like this. From here, we're going to solve for T. And to solve for T, we're going to divide both sides by log of B. And when we do that, we get our time is equal to 25.84 years. That is equal to our half-life. So that's how we do the first section of the problem for the half-life, and now we need to find how much we have in 2050, which is a little bit easier. So I'm going to do that part right here. Okay, so now we're going to find the amount of the substance we have in the year 2050. So we're going to use the same equation again. We're going to go with S is equal to A. And this time we know our half-life, so we're going to use big B for this to the T, because that's our stored value of our half-life. And then we're going to solve for S, and we know that our initial amount is 500. We have our B value in our calculator already, and then we find the amount of time from 1953 to 2050, and that is 97 years. So you're going to put this into your calculator, and what you'll get out is S is equal to 37.07 grams at 2050, which makes sense because we have less than the amount at our half-life, and this time is a lot farther than our half-life. So this is our answer to the second portion of the question.